In section 11.3, we'll talk about the product rule and the quotient rule. So we need these two special rules because taking the derivatives when you have a function that is the product of two different functions, it's not as easy as simply saying, for example, if you had a function y is equal to f times g, the derivative is not the same as just f prime times g prime. That is not going to work. It has to do with the limits and where the derivatives come from. So you can't just take the product of the two parts, the derivative of the two parts, and then take their product. Instead, we have to use what we call the product rule. And the product rule is written right here in the box. It says, when you have two functions multiplied together and you take their derivative, then you get f prime g plus g prime f. So you have to acknowledge where the derivatives are being taken and where they are not being taken. Here is f prime, that's the derivative of f. This g is the original g from the function that we're taking the derivative of. This g is a lot of times what I would call unchanged. It's the original g from the beginning. Plus g prime times f. Let's go ahead and take a look at example number 1. We want the derivative of x squared plus 2 times x minus 3. And yes, certainly you could multiply this out and then take the derivative with just the power rule that we've used. But we're trying to learn a new skill, so we're going to go ahead and do this with the product rule. So notice here is f, and here is g. This is the product of two functions. We will take the derivative of this first function. What is the derivative of x squared plus 2? 2x. Times the g left unchanged. So it's the original x minus 3. Plus, what is the derivative of the g function? Yeah, the derivative of x minus 3 is just 1 times the original f function, unchanged. And then we multiply and simplify. So this would be 2x squared minus 6x plus x squared plus 2. And so that's 3x squared minus 6x plus 2. Okay. All right. Questions over example 1. All right. Example 2. We have y is equal to the square root of x times 7x cubed minus 2x squared plus 8x minus 12. The first thing is to identify the f and the g. So the square root function, square root of x, is f. And then g is all of this. So the derivative would be f prime g plus g prime f. So we take the derivative of the square root of x, which is 1 over 2 square roots of x, times the g function, unchanged, plus the derivative of the g function, to be 21x squared minus 4x plus 8 times the f function unchanged. All right. We need to simplify. And first we will distribute the 1 over 2 square roots of x into each of these 4 parts. So the first one would be 7 over 2. All right, now let's think about what we're going to get when we have x cubed over the square root of x. I'll remind you that if you take x and divide it by the square root of x, you get the square root of x. Right? Because x is really x to the first power. The square root of x is really x to what power? The 1/2 power. If you have x to a power divided by x to a power, you subtract the powers. So this is x to the 1 minus 1/2, which is x to the 1/2, but x to the 1/2 is the square root of x. Okay. So we're going to use this simplification throughout this piece. Here we have x cubed divided by the square root of x. Using one of the x cubes, I can do my simplification and get a square root of x. That left 2 other ones. So that is x squared root x. Next, the 2's cancel. And then we have x squared divided by the square root of x. So that is x root x. Next, 8 over 2 is 4. X divided by the square root of x is the square root of x. Next is 12 divided by 2 is 6. And in the denominator is a square root of x. On the right side, we have 21x squared times the square root of x. So that's 21x squared, square roots of x, minus 4x square roots of x, plus 8 square roots of x. All right, let's combine like terms. Like terms are based on the powers of the x. What is the highest powered term here? Which one is the highest?
X squared root x.
Yeah, x squared root x. That's technically the power of 2.5. Because you get x squared is 2, and the square root of x is another half, so that's 2.5. I have one term here, and I have one term here. What is 21 plus 7 halves? If I turn 21 into halves, that would be 42 halves. So 42 plus 7 is 49. So this is 49 halves, x squared root x. Next we have x root x. There's minus 1 on the left. There's minus 4 on the right. So that's minus 5x root x. So that's this one and this one. Next we have 4 root x and 8 root x. That's 12 root x. And I'll put little triangles on those. And that leaves this last term of negative 6 over root x. So there's going to be some combining that you have to do. All right. On example 3, we can do this one, but we have to rewrite it. The first part is okay, but the last piece has to be rewritten as 3x to the negative 3 power. So here is the f, and here is the g. So if we want the derivative, this would be the derivative of f, which is 10x to the 4th plus 3 times g, unchanged, plus the derivative of g, which is negative 9x to the negative 4th, times f unchanged. And then you would simplify. So we have 30x plus 9x to the negative 3 minus 18x minus 27x to the negative 3rd. All right, what combines? Mm-hmm. 30x minus 18x is 12x. What about 9x to the negative 3rd minus 27x to the negative 3rd? That combines. That's negative 18x to the negative 3rd. And then we need to rewrite this with positive exponents because that's how the problem started at the top, positive exponents. So this is 12x minus 18 over x cubed. All right, questions? Let's take a look at example 4. Example 4, y is equal to x times f of x. So what is, y is equal to x times e to the x. So what is the f and what is the g? F. And then the e to the x is the g. Alright. So we have y prime is equal to the derivative of f, which is 1, times g unchanged, that's e to the x, plus the derivative of g, e to the x, times the f unchanged. Now, for this one, the normal way to simplify this is to factor out the e to the x, and then put the rest of it in descending terms. So we have e to the x, and then we'd have 1 plus x, which we normally write as x plus 1, to make it look like a polynomial. All right, go ahead and do example 5 with your partner. All right, let's check example number 5. So we have y is equal to x squared plus x plus 1 times e to the x. The x squared plus x plus 1 is the f. The e to the x is the g. So we have y prime is equal to the derivative of f, which is 2x plus 1, times e to the x, unchanged, plus the derivative of e to the x, which is e to the x, times x squared plus x plus 1, unchanged. Simplifying, we factor out the e to the x. We get 2x plus 1 plus x squared plus x plus 1. And combine like terms. This is x squared plus 3x plus 2. That's it.
For the answer, do you always want to use back it up?
Yeah, that's a good habit to get into, because when we get into chapter 12, when we actually start using these to solve problems, you'll need to factor it out before you can solve it when it's equal to 0. All right, go ahead and do example 6 with your partner. All right, let's check it. So we have f, and we have the g. So y prime is the derivative of f times, which is 1, times the natural log of x, unchanged, plus the derivative of the natural log of x, which is 1 over x, times the original f, which is x, unchanged. And so 1 ln of x is ln of x plus 1 over x times x is 1. So it's ln of x plus 1.
So you just do times x over 1, 1 over x times x over 1, and that equals 1.
Yeah, the derivative of the ln function is 1 over x. All right, let's look at example 7. What's the problem with example 7? There are 3 of them. So the product rule allows us to do 2 at a time. So that's what we will do. We will group it. And let's group it here and here, like so. And inside this, we will have, the overall scheme is the following. Here is F, and then here is G. Okay? And so this is what you get. Now I'm going to write this in symbols, in derivative symbols. Okay, so you can see what we're getting here. So y prime would be the derivative of f. So it would be the f function, which is that product, and its derivative, times e to the x unchanged, plus the derivative of e to the x times the f unchanged. Okay? So I haven't actually taken any derivatives. I've just written down that we're going to take derivatives. Okay? Now, to simplify this, the first thing that we need to do is find the derivative of x squared plus 1 times 3x plus 2. That in and of itself is a product. So in order to do just this piece of this problem, I have to invoke the product rule again, sort of within itself. So here's another f and another g. All right. So here we go. Simplifying this, we're going to use the product rule on this inside part as well. The derivative of f is 2x times the g unchanged plus the derivative of g, which is 3, times the f unchanged. And that is just the derivative of this first part right there. Times e to the x unchanged plus the derivative of e to the x, which is e to the x, times x squared plus 1 times 3x plus 2 unchanged. All right. Now to simplify this, we need to just multiply these polynomials out and then factor out the e. So I'll factor out the e to start with, and then we multiply. So we get 6x squared plus 4x plus 3x squared plus 3. And that's the left side. From the right side, we get 3x cubed plus 2x squared plus 3x plus 2. And simplifying this, the highest power is cube, so we have 3x cubed. Next highest power is squared, so I see 6, and 3 is 9, and 2 is 11. Next, we want to add the x to the first power terms. There's x to the there's 4x, and then 3x, so that is 7x, and then 3 and 2 is 5. There she is. All right, questions? All right, let's take a look at example 8. Example 8 is y is equal to the natural log of x squared times the square root of x. And we don't know another one of these rules that we have to learn today, so we have to change this algebraically before we can do this one. There's a rule that says if you take the natural log of something to a power, then that power can come to the front. So this is really 2 natural log of x times the square root of x. And from there, we can isolate the f and the g, and we can take the derivative. So y prime is 2 times the derivative of the natural log of x. So that would be 2 over x. Times the square root of x unchanged, plus the derivative of the square root function, which is 1 over 2 square roots of x, times 2 natural log of x, unchanged. What cancels? These 2's cancel. What about these x's over here? How do they cancel? Top or bottom? Close. Bottom. See, the x to the first power is the larger of the 2. So, because this is x to the first, this is x to the 1/2. That's in the top. So the result ends up where the larger exponent was. That would be the bottom. So that simplifies the square root of x. So here we have 2 over root x plus ln of x over root x, which is 2 plus ln of x over the square root of x. Questions? All right, go ahead and do example 9 with your partner. You got to be careful about where these things are split up. See? This is this plus this. That's not the product rule on the big scale. It's the product rule on small scales. Right? This is 4 to the x times x cubed. So you're going to use the product rule on this piece. This is e to the x times x squared. You're going to use the product rule on that piece. Then you're going to add those results. Because remember, if you have like x squared plus 2x, you take the derivative. That's just the derivative of that one plus the derivative of that one. All right, let's check it. So on the small scale, we have an f and a g here. So y prime is going to be, what is the derivative of 4 to the x? 4x, ln 4, times x cubed unchanged, plus the derivative of x cubed, times 4 to the x unchanged. So that is the derivative of just this first piece right here. Next, we add on the derivative of the next product. So we have another f and another g. So the derivative of e to the x is e to the x times x squared unchanged, plus the derivative of x squared, 2x, times e to the x unchanged. And then what is the derivative of pi to the e power? That is 0. Pi to the e is just a number. Probably about 20-something or so. So that's just a 0. All right. And then are there any like terms? I would be surprised if there were like terms. There are no like terms, so that's it. Then just add it on. Yeah. Plus 2x. Yeah. You just add it on. Yeah.
So you don't do the quotient rule for just one single by itself. It has to be
Or more. Yeah. All right. All right, so that's the product rule. Let's look at the quotient rule. Quotient rule is for when you're dividing two functions. So the quotient rule is f divided by g. The derivative of that quotient is f prime g minus g prime f over the original g function squared. Usually we don't multiply out the g squared part for reasons that we will get to in Chapter 12, where we need to solve when it's equal to 0 and stuff like that. So usually you just leave that alone if that's okay. All right. Example 10, we have y is equal to x squared minus x plus 2 over x plus 3. We need to identify f and g. F is the numerator and g is the denominator. So y prime is the derivative of the numerator. So this is 2x minus 1 times g unchanged minus the derivative of g times f unchanged divided by the denominator squared. We do need to simplify that. But before we do, let me make mention of this very common algebra mistake. A lot of people are tempted to try to cancel this one and one of these. Right? You have this is squared and this is that there. Can you cancel? No. Why not? Yeah. You can only cancel if it's multiplied this times that, and you're canceling off a factor. This is a factor of this part, but it's not a factor over here. Right? So if you were going to be able to cancel off an x plus 3, you would have to have first factored it from both parts. You see, on the grand scheme of things, there are two pieces in the numerator. Here's the first part, minus, here's the second part. The terms are separated by pluses and minuses. In order to cancel, you need factors, which are multiplications. Okay? So this does not cancel with one of these. It stays there. Now we'll go ahead and simplify. Oh, not much room to simplify here. All right, this is 2x squared plus 6x minus x minus 3 minus x squared plus x minus 2 over x plus 3 squared. And so what do we have? X squared 6 plus 6x minus 5 over x plus 3 squared. Questions over the quotient rule? Now, one thing I will mention is that I've set up the product rule and the quotient rule so that they look basically alike. In the top, you have f prime g and g prime f. The difference between the product rule and the quotient rule is the product rule has a plus and the quotient rule has a minus. You also have to divide by g squared in the quotient rule, but I think everybody remembers that. The part people forget is the order in which things come, and then whether or not to use plus or minus. You use plus when it's the product, multiplication. You use a minus when it's division. Okay, pretty straightforward. Other resources, books, videos, and everything, the quotient rule is fine. A lot of other books will give you the quotient rule, the product rule flipped around. It's the same because it's addition, and you can flip addition, but they talk about it in a different order. Why do they do that? I don't know. It just seems like it's easy to do it the same and then just change the sign in the middle. But I don't know. All right, let's look at example 11. We're going to do this one. We're not going to simplify too many more of these. You just have to simplify them. I'm sure you can do that. So identify f and g. Take the derivative of f. So that's 9x squared plus 16x minus 12 times g, unchanged, minus the derivative of g, which is 400x minus 3x squared, times the numerator, unchanged. Running out of spaces here. That's not a power. No, okay, let me see if I can rewrite that. $400x minus 3x squared times 3x cubed plus 8x squared minus 12x minus 4 over 200x squared minus x cubed squared. And that's it. Questions?
That's it.
Well, you would simplify it if you were going to put it in the computer. We're not going to take the time to simplify too many more of these. We got another section to do today, so we got to roll on here. All right, go. Depends on the question. Mm-hmm. Usually, I ask like a whole, like one problem with like 10 parts to do a derivative, but But I don't know. This summer your tests are shorter and stuff, so I don't know if I'll do that. Who knows? All right, go ahead and do 12 with your partner. Don't simplify. Don't simplify. Just take the derivative. You'll need plenty of practice to simplify when you do something. Don't forget we have treats up here today. We have Hershey's milk chocolate. I actually went to Hershey. Went to the sugar. It's pretty good. I went to Louisville a couple of times.
Where's that at?
I went to the Ben and Jerry's place.
You see all the flavors in that? They have like a wall.
1998, yeah.
You said no, some flat.
You can't promote it. I'm not Oh, well. All right, let's check it. So first we identify f and g. We take the derivative. So it'd be 16x plus 3 times 5x cubed plus 15x squared minus 6 minus 15x squared plus 30x times 8x squared plus 3x minus 1,000 over 5x cubed plus 15x squared minus 6 squared. Questions? All right, let's take a look at example 13. Have quotient, so we have f and g. So this is y prime is equal to the derivative of f, which is e to the x, times the bottom unchanged, which is x, minus the derivative of the bottom, 1, times e to the x, the top, unchanged, divided by the bottom squared. Let's simplify this one. It's short. What would you factor out from the numerator? E to the x. So this is e to the x times x minus 1 over x squared. So in particular, I remember one of the problems that I assigned for your homework was something that looked like this, and then one of the questions was find the derivative, and then the next question was find where the derivative is equal to 0, right? So if we sort of added that part in here, right? Where is f prime equal to 0? Then if the function is equal to 0, you set the numerator equal to 0. And then you split this up. So this would be e to the x equals 0 and x minus 1 equals 0. Well, x minus 1 equals 0 gives you x equals 1. And then e to the x equal to 0 is no solution. Remember that the graph of e to the x is this exponential curve. and it never equals 0. It has a horizontal asymptote at 0, and it just slides in there just like that, but it's always positive. So anytime you get to set e to the x equal to 0, that's not going to result in a solution. So what is the only 0 here? It's just x equals 1. They can ask you that question in other forms too, right? Like, since it's the derivative is equal to 0, the derivative is the slope of the tangent line. If the slope of the tangent line is 0, that's a horizontal tangent line. All right? So that's the same as horizontal tangent line. Yeah. All right, go ahead and do example 14 with your partner. Let's check it. So we have f and g. So we have y prime is the derivative of f times g unchanged minus the derivative of g times f unchanged divided by g squared. Now, you have to be careful when you put in the square here. If I just put it here like that, that is not g squared. That's the natural log of x squared. So what you have to do is you have to put parentheses here. This is in particular with the natural log function. So it has to be the natural log of x, quantity squared. You could simplify that. There's not much to do. It's just that piece is an x, and that's it. All right. Let's look at example 15. What do you have to do to find the derivative of example 15? Do we have a quotient? We have a quotient. So we have an f and a g. Now notice what the f is. The f is a product. So in the process of doing the quotient rule, and you do f prime, you'll also have to do the product rule. Because you have an f and a g, another f and another g. That's from just the top part. Let me demonstrate. So, y prime is equal to the derivative of the numerator. The numerator is a product. So in order to do that derivative, we have to use the product rule. So it's the product, it's the derivative of x times the second one unchanged, plus the derivative of e to the x, which is e to the x, times the x unchanged. So everything in those brackets is just the derivative of the numerator. Now, continuing with the quotient rule, times the denominator unchanged minus the derivative of the denominator, 2x, times the top unchanged, x e to the x, divided by the denominator squared. Questions? You want to see it? Okay. I'd probably do the following. We have e to the x on all these terms. So this is x plus 1 times x squared plus 1 minus 2x squared. And that's around a big set of parentheses. Because I factored out e to the x from here, which put it in front with this whole term. Right? So when I factored out e to the x here, I now have e to the x times something. And then I have an e to the x over there. So I factored out an e to the x in front of everything. And then this piece is 1 plus x times this minus these three parts, 2x squared. We've got to simplify that in the next step. So it's e to the x times x cubed plus x squared plus x plus 1 minus 2x squared over x squared plus 1. And so that would be e to the x times, so what do we have here? X cubed minus x squared plus x plus 1. Other questions? All right, go ahead and do 16 and 17. You do not have to simplify. I'll check those in a moment. If you need to take a break, now would be the appropriate time. Because right after this, we're going to go on to the next section, and it is intense. Okay, let's go ahead and check 16 and 17. So we should have an f and a g. So y prime is the derivative of 4 to the x. That's 4 to the x, natural log of 4, times the bottom unchanged, which is x to the 4th, minus the derivative of x to the 4th, which is 4x cubed, times 4 to the x, divided by the bottom unchanged. And you can either write this as x to the 4th squared or simplify it right away to x to the 8th. For 17, you have an f, you have a g. So y prime is the derivative of log base 8 of x. The derivative of log base 8 of x is 1 over x times the natural log of 8 times the bottom unchanged minus the derivative of the bottom, 3x squared plus 2x plus 1, times the top unchanged divided by the bottom squared. Questions?